Okay, class, as we continue with the whole lesson on Cisco subnetting, we're going to talk a little bit about understanding the magic number. But before, we're going to talk about classful net mask and the first identify the network portion and the host portion of an address, and what makes it so difficult when we start with the whole concept of classless. So, for example, in a class C or /24, we have the 255 is going to represent the network portion, the 255 and the 255, as you can see below here, and the 0, which is basically represent the host portion. Right? Class B, we got 255 in this case here, so there will be two networks, and you have all this here, which is considered as hosts. Same thing for class A, we have the first portion, which is considered the network portion, and the other octets is considered as the host. And this is a very difficult concept to subnet when we are using class A. Hence the reason we need to master class C and then move to class B, and then we would be able to master subnetting on class A. So class C basically is a /24, which is classful. We have identified a classful net mask where we have the entire bit here is 256 basically when you check up all the place values. So basically we use /24 and we use the entire network, and we draw a circle to make it to understand the whole concept of subnetting and when you're moving bits and so on. So here it is now that we have 192.168.1.55, and sometimes in the CCNA they ask you, is this a usable host address, and sometimes it's asked you, is it a network address, is it a broadcast address? And if that is the case, then if it's not, well, if it is a usable host, then what network it is in. All right, so here it is that we have our class C classful, but the only difference is now with this one here, we're going to borrow 2 bits. All right, since it's a /26. So here it is, we have 192.168.1.55 and a /26, and we have to identify what is the net mask here. So we're going to borrow 2 bits. All right, so that would be 24, 25, 26. All right, so basically, as we borrow these 2 bits here, all right, I'm going to put it in a little color code here to understand the whole concept of the magic number and why it is important for us to understand the magic number. All right, and the magic number basically is the last borrowed bit. All right, in this case here, the last borrowed bit is 64. All right, and 64 here is what we considered as our magic number. And why is this important? Because our magic number actually tells us how networks are incremented by. All right, so for example, our first network would be 192, right, .168.1.0, right? And our next network, as you add 64 to it, would be 192, and I'm going to just copy and paste this, right? 168, right? 64. And if you add another 64 to that, you would get 128, right? And of course, you're going to get, if you add another 64 here, 192. Okay? So what does this really tell us here? Basically, that if we was to look at the place values, we know it's 128 and 64. And if we was to add up 128 and 64, we would get a net mask of 192. And this is how routers again interpret through the process of handling to get a specific host in a network. Now, the interesting thing about understanding the magic number that it increments in terms of the networks, we now could also derive the broadcast address, which basically the broadcast address would be, I'm going to copy it here, all right? So this would be up to 192.168 up to 63, because the next network starts at 64, right? This one would be 127, because the network starts at 128. This one will be 191. Alright, and the last network, as you could guess, will go up to 255. Alright, so what this basically tells us is that 55 is in the first network, which basically is between 0 and 63. And what this also tells us also that you have only 62 basically usable hosts because of the magic number, which you only have between 1 and 62, right? Usable hosts, because you can't use 0 and you can't use 63 because 63 is a broadcast address and 0 is considered as the network address. This one here will tell you the same thing. Usable hosts will be between 65 and 126. Okay, and I should put this in red just not to confuse you all too much. Alright, in terms of usable hosts. Alright, put it in purple in fact. Alright, and the other network, which is this one here, the usable host between 129 to 190, right? And the last one will be between 193 as usable host to 254, right? So basically, this magic number identifies also the number of networks you would get, right? In this case, we get 4 networks. It also tells us with these networks, we could derive the network address as well as the broadcast address. And as you can see, the broadcast address in this case would be 63, 127, 191, 255. The network would be 0, 64, 128, and 92. So if it was to ask you a question, 55, is it a usable host? Yeah, of course it's a usable host, and it is in the first network or subnet, which is 0 to 63, right? The only things we have to understand is how do we determine now the number of networks per subnet. And of course I will do 2 other videos to show you all this. So I'm going to move across here now to my notepad, and I'm just going to put 62 here in this case here, and write it in dotted down decimal notation 64, right? Okay, so I'm going to just bring down this a little bit. So basically on my place values, I'm going to put my place values a little higher up and put it in a different panel entirely. So this would be 1, 2, 4, 8, 16, 32, 64, 128. Right, so I'm going to go in a different pen to identify my networks now. So because it's 128, we would get only 2 networks, right? And basically, how do we arrive at that? And 64, we identify that 64 is only getting 4 networks, but we get 64 hosts, which is only 62 usable, all right? Because one have to go to the network address and the other one have to go to the broadcast address. If it's a /27, you get 8 networks, but we get 32 hosts, but we only get 30 that is usable. So basically, if I was to draw one big circle here, tend to draw the circle, right? This entire network is one network here, so it's a /24, which you will get up to 255 hosts, or 256 basically, which is only up to 254 hosts going to be usable. And if I was to break this down here a little bit, and come down here a little bit, and go to our /28. So I have 2 networks here, so /28. So my first network will start from 0 to 127, and my next network going to be from 128 to 254. All right. Again, if I had borrow 2 bits, which is 64, I'm going to draw a next circle here, then I would have 4 networks. So I'll have 64, 64, 64, 64, which is 4 networks, and we identify in terms of 0 to 63, yeah, and so on, 64 to 128. All right, and we could identify this, and we'll go down even further again. You do all this again, you get 8 networks, which is a slash 27 in this case, which derive now 32 hosts. So this one here is going to give us 16 hosts and 16 networks. This one here would give us 32 networks, 8 hosts. And this one here would give us 64 networks. But this would give us 4 hosts. And of course, you could only have 2 usable hosts here in this case. So 1 and 2 is definitely ruled out because you wouldn't be able to get any hosts here because you wouldn't be able to use the broadcast, or in other words, the network address. So we normally stop at a slash 30, which you're going to learn in later classes like Network Management 2, Advanced Routing Protocols, and so on. So this is how we arrive at knowing how much networks versus how many hosts. So as you can see, I kind of like backtrack a little bit. 128, 2 networks, all right? 128 hosts. 64 give us 64 hosts, 4 networks, and so on. All right?